So this is the second workshop in the series of two as an intro to blockchain. Last week, we talked about Solidity and how to build smart contracts for Ethereum and other similar chains. This week, we're going to go into the interfaces like websites, applications that connect to those blockchains. Connect those smart contracts. And the whole space that this is about is called Web3. So I'll explain a bit more about that. So Web3 is just the suite of applications that don't have a backend and instead have smart contracts that they connect to. This because the blockchain is decentralized in most cases. It creates a decentralized internet where all the data is stored across all the users. So this is why we call it Web 3. Web 1.0 was where data was dictated by the big companies, and they dictate what goes on their site. Web 2 was more of users uploading and sharing content, yet the applications themselves are still centralized. Web 3.0 takes that to the next level where also the data is decentralized. This is really like, I don't know, some people have been hating on it recently, but there's I don't understand why. It is really cool because it's resistant to so many things. Like if Amazon Web Services just shut down, your app is still going to be up because it's distributed across a bunch of machines and across the world. Yes, there are multiple data centers and there's always going to be backups, but this is just user generated. It's also like if Amazon Web Services decided that they didn't want you on their platform, you could host it in a decentralized way on the blockchain, and nobody can dictate what you can host or how you can operate your product. So I'm just going to dive into it. I don't have a whole lot of slides. This will be more of a hands-on workshop. And the way that Web3 works is it's very similar to a normal Web 2 application. You have your JS, HTML, and CSS app, and then you also use a connection to the blockchain. And so the package that I like to use, and it's most common right now, is called Ethers. And this is just like another API that you can use, just like any other JavaScript API. And this will allow you to connect to a blockchain or a network, decentralized network. When you are connecting to the network, you would connect to the contracts individually, and you need some information on them to be able to connect to them. You need the contract address, the contract specifications, which is a JSON JSON object. We call this an ABI. And those two, you also need a provider. And so those three, combine together to find that contract on chain, on the network. And that'll make more sense. Here's another diagram to kind of make more sense of it. This Metamask is a browser wallet. As I said in the last workshop, every person interacting with the blockchain uses a wallet. Metamask is a browser extension that holds your wallet, and it injects a provider into the global variables of your website. And so that provider is your connection to the network. With a normal with a normal API, you can just use HTTP. But since this is connecting to a different network, you need a bridge, which is a provider. And that provider is in the form of an HTTP URL, but it will take your request and then convert it into a request for a decentralized network. And so the way that you would query a contract would be to go through Ethers.js, and we will have to use a provider or a signer. This is usually in the form of a browser wallet, but it can also be a external URL that you just use. There's hosts like Infura is one, and they will provide you with a URL so that users don't have to have a wallet to view your site. That signer there is a little bit different. You need a signer in order to create a transaction, and you can't get that with something like Infura. Then you can connect a contract to that signer and make a request to the blockchain. And so that's actually all my slides for today. Last time it was a bit more, but I'm going to just do more of a hands-on approach, explore some of the current Web3 applications. We're going to start actually by installing your wallet, Metamask, and then we can take a look at some applications that currently are like industry leaders in the space. And so I don't usually use Firefox, but I'm going to use it to install MetaMask. So if you go to metamask.io and hit download, I'm just going to add that to our browser. Oh, okay, there we go. Cool. And this will take us through getting creating a wallet. I'm trying to think. We will be importing a wallet. Okay, we're going to create a new wallet. And I'm going to just create a test one. I'm going to save that. And so this is something that every wallet has a seed phrase, a public address, or a public key, and a private key. This seed phrase that is behind this, I'll share it because this is a throwaway wallet. I'm not going to be using this for anything. This is where you can restore that public key and private key from. This is the only way to generate that public key and private key. And so you want to keep this in a safe place. I'm just going to go through this without saving it. I believe I actually need to type this in the next stage. So I'm just going to take a screenshot. And if you have a piece of paper, go ahead and write that down. And again, you don't want to share this with anybody. This will allow people to access your wallet if they have it. And so it will ask you also to confirm your seed phrase. So I'm just going to space smart fabric. Cool. And then we have our wallet. So maybe I'll give a little minute if you need to write down your phrase. And so now this wallet will allow us to connect to any Web3 application. You can see that we don't have any Ethereum. This is our public key up here. And if we want, we could buy Ethereum through one of these ways, or I like to use ShakePay. It's a Canadian site, and they allow you to buy Ethereum or Bitcoin or anything. And then it will show you your assets here. So again, we don't have any Ethereum, and then we can see we don't have any past transactions either. What we can do is from here, take a look at some of the kind of biggest applications in the space right now. And the first one we're going to look at is OpenC. And I'm sure if you've looked at NFTs at all, you're familiar. OpenC is right now the #1 NFT marketplace. And there's so many, like every NFT you can think of is on here on the Ethereum network. And you can explore and buy NFTs with your Ethereum. If I were to place a bid, I can connect my wallet, and this will ask me to connect my wallet, and we're now connected. You can see I have 0 USD, so I think if I try and place a bid, it will ask me to sign this. A signature is a transaction that you do not have to pay for. This just uses your private key to verify that you're the one connecting. I can sign this, and then we'll say like I don't have the amount of tokens. Another cool one we can check out is Wearable. Wearable is another, I would say, the second largest marketplace for NFTs. A cool thing that they just released recently, and if I sign in with Metamask, I can take a look. So this allows me. And let's see if I can find this feature. They added the ability to message other people, which is not something that's actually that common. I can't find it at the moment, but yeah, this is Wearable is another big one. It's pretty similar to OpenC, and just another NFT marketplace. There's also exchanges, and the biggest one, which was released in 2017, I believe, or 2018, is Uni Swap. And this is where you would come to swap for tokens. And so if I had Ethereum, I can choose an exit token, and I can put in like 1 Ethereum. And if I wanted to connect my wallet, it will take me through connecting. And it'll say I have insufficient ETH balance. When we do our application, which will be just after this, I'll show you more about how transactions work. And you'll see more of, it'll tell you what the fees will be and take you through a transaction through your Metamask. But this is just your gateway to the blockchain, and will allow you to create any transactions with your Ethereum. Cool. So let's just get into what we're building. We're going to take the application that we used last workshop, and I added some more in there, one more commit. So make sure that it's up to date, and I'll paste these links in the chat so that you can clone them. And so one of these is our, this one I just sent is the contracts that we'll be using. And so it's a repo that holds our smart contracts. And then I will also send the front end that we'll be working on. I just made a boilerplate with create React app, and then added another package in there, ethers JS, as well as just a component library to make things smooth. Give you a second to clone those down. And so I'm just going to CD into the Solidity one. And this again is our smart contracts. And what we're going to do for our development practice will be to run a network on our local machine. So rather than connecting to Ethereum and all good. Rather than connecting to Ethereum and paying $1,000 to deploy our contract just to test it, we're going to be using our local host. What I normally do with my development is develop the smart contract and release on a test network such as Rinkeby. These test networks are free, and it is a pretty smooth solution once you have the contract fully developed. But for this experience, we want to be able to. It should just be a smoother experience to use our local hosts, is what I'm trying to say. So we can do that by typing in npx hard hat node. And what this does is it gives us a bunch of addresses. And these addresses are, I believe there's 20 of them. And it gives you the public key, the private key used to sign transactions, and then it starts every account out with 10,000 ETH. And so this is just our local network, and we'll be deploying our contract to it and connecting to it from our Metamask. And so I'm going to open up a new terminal, and I'm going to go into the same folder, the Solidity, and I'm going to deploy the contract. So I'm going to go npx hard hat run network localhost and /scripts deploy. And so what this will do is it will deploy our contract to the network, and you can see here contract deployment token. And in that deploy script that I wrote, it also called mint to give the minter a few of the tokens. And so this is cool. You can just monitor your local network and see all the transactions that happen, and it's pretty handy to have. As we learned, I believe in the last section, is that the first wallet through Hardhat is always the deployer. I can try to zoom in here a bit more. So the first wallet is always the deployer, unless you specify otherwise. So if we were to check the token balance for the first address, it will be 200, is what I set in the deploy script. What we're going to do now, because we need to we're going to be using our browser. And so because we started this local host chain, none of these addresses are the ones that we just set up. These addresses are predetermined, and we will need to take one of these addresses and add it to our MetaMask account. We can do that. By opening our browser, going to MetaMask, and clicking on the top right here and import account. And so this is pretty easy to do. You can just take the private key, close, go back into import account, and just paste that private key here. And now we're on Ethereum mainnet, and we just want to switch that. We want to show test networks. And this should give us, yeah, localhost 8545. So you can connect to that. And I believe, yeah, we'll have 10,000 ETH. Just below it, because we were the deployer of the contract. But yeah, this is our wallet on our local network. Okay, cool. Now we can start to build our front end. We have our network and our contract deployed. We should now open up this new window, and we'll navigate to the React application, that the other repo that you found. Be called Web3 intro. And what we can do is we can just run yarn, make sure our packages are installed, and then we can run yarn start. And then what we can do is we can navigate to localhost 3000. Cool, we have our boilerplate here. I'm realizing I'm on the solution. So I'm just going to open the Web3 intro repo in my editor. And change. To be honest, I'm not a VS Code user, so I'm just going to change it on my other one quickly. Cool. So we're back and ready to go. So I'm going to take a look at this again. And if we remember, we installed our Metamask, and that injects the provider into our web page. So when we were on OpenC and we connected our wallet, we then got the provider, and we could see all the tokens on the network. Then we need our contract, which is our ABI and our address. And then through that, we will connect to the blockchain. So I'll take you through each of these steps. First, what we're going to do is create a way to connect our wallet. So we can open up our React app. Hopefully you all have an idea of how React works. This will be based on a bit of knowledge, but hopefully you can also just follow along if you want, and you should be fine. So what I'm going to use, I'm using a package called React, or Chakra, and this is just a library with UI components, just to make it look pretty. So I'm going to add a button here, replace the header with a button. And I'm just change the background to green, and the color to white. And we'll make it say connect. sure I have my other notes up here. Okay, so what we need to connect to our Metamask here, we see we're not connected. So what we have to do is import our ethers. So we're going to import our ethers package from ethers. And then we're going to also use state and use effect from React. So we'll also import use state and use effect. Cool. Now we want this button to do something, so we're going to use an on click. We're going to pass in a connect wallet, and we got to create that function above. And as we said, we're going to need our provider and signer here. We're just going to use those as state variables. So I'm going to use state for that. So we'll go const provider, set provider, as well as the signer. And then we're also going to grab the address. Once we have that, we can grab the address from the signer, but we're just going to store that in the state too, so we can display it. So the first thing we can do is we can get the provider once we click connect wallet. So we can just do that by, we're going to name it new provider, so we don't pull the state in. And it's going to be a new object from ethers.providers web3 provider. And we just got to pass in that global object that gets injected. And cool. Oh, sorry. That should be window.ethereum. Cool. And that is all we have to do to the provider object that gets injected by Metamask. And all this state and components down here, this is just for React. The main thing that you want to take from this is just the ethers. And so again, we want that provider, and then we're going to get the signer. So you want to make sure that that provider was recognized. So if there is a provider, we're also going to get the signer. So we're going to call that new signer equals new provider dot get signer. Cool. And then from that signer, we can also get the address. This probably isn't best practice, but just for the ease of use, we're just going to go set provider, new provider, to set that state, and set signer, new signer. And then what we can do after that is once we have the signer, we can get the address. And this is an async function, so we're just going to do a then to get the result of that. Async just means it's not in line, so it won't happen right away. And we need to provide a function to call after it's executed. So we're going to put in the address here, and then we're just going to set the address with that value that we get back. Cool. What we can do is we can display that address instead of the button, because we don't need to connect anymore. So, just go address. We also don't want to display that unless we've connected. So we're just going to put in an operator here to check that they're if there is an address, we're going to display that text. Otherwise, we're going to display that button. And we also need to import text from Chakra. Cool. So now if we click this button, we can check just to make sure not connected. And if we click this button, unknown account 0. Okay. Also get addresses. Let's see if that fixes it. Mm-hmm. Let's see what's going on in the terminal. I don't know how to use Firefox terminal. Let's see what's going on here. There's 0. Let's check what that new signer is. Interesting. Okay. Well, I didn't have this happen when I was setting it up. So let's see. Could it be? Could be a differing version of. Let's see. I think it may be because Firefox has a different version of Metamask installed. So I'm actually just going to switch over to Chrome just for the sake of this, or Brave. And is it going to give me the same error? That's odd. Okay, let me check my notes, see what went wrong there. Apologies. Very odd. I'm just going to check. We've okay. Very weird. I'm not sure quite why that happened, but I took my solution and it was working. So if you need to reference that, you should be able to find it from there. Apologies for that. A little bit tired. Okay. Now that we have that, we can see that our wallet is connected, and we can also see it's connected there. So we can use it to make some transactions now. So what we're going to do is the first thing that we need is our contracts, or our contract. And we deployed that down here. But if we take our terminal that we used to deploy it before, and we can see that it was deployed to this address. So we're going to copy that, and we're going to put that into our code. Contract address. We have that, and then the other thing that I had mentioned before is we need the ABI. And so the ABI is just a JSON object that describes all the functions and the, sorry, I got distracted by the chat, all the functions as well as the events and things. Sean had asked, so if you wanted to accept Ether as a payment on your web app, you could use Ethers.js like this. I would recommend using probably a pre-configured package. This is just to show you the basics. But yeah, so we have that contract address. We also want the ABI. So what I'm going to do is open our other project that we have, the Solidity repo. And we can go to artifacts, contracts, and token.json. Going to open that. And we can see our ABI is here. So I'm just going to copy everything within the square brackets here. And we're going to go through our, we're going to create a new folder, name it contracts, within the source folder. And then we're going to create a new file, and we can call it token.json. And we can paste that in there. We also want the square brackets. So I'm going to fix that. And then we can import that into our app. And we're just going to go import token ABI from contracts token.json. Cool. So we have that contract address and the token ABI. Then we can combine it with a provider and create some transactions. So what we're going to do is we first have to attach this address and ABI to an object, to the actual contract object. So we're going to add a state in here and name it contract. And then what we want to do is we can just use a use effect to check when the provider changes. That is the one thing that we'll need that changes. That is a state variable, and then the contract address and the token. So we're just going to make sure that the provider is there, and we'll set this provider as a dependency. And then what we want to do is we want to create the contract. So we can take token, name our contract token, and then we're going to go new ethers dot contract, up in the contract address there, the ABI, and the provider. Cool, and then we can set our contract to the token. And I'm just going to say user address for clarity, because we're going to add our token balance next. So yeah, now that we have this contract and it's available, we also, if we want to display the token address, we have to call a read function on the contract. And we're going to add in another, actually, let's go and add into the state. We're going to add a token balance. And then we can go down to the bottom, and so we want to add another use effect. And we'll add the contract and address as dependencies. And then we want to just make sure that if both of those are defined, then we want to try and use the contract. So we're going to go contract dot, and then if we look at our ABI, we should have a function in here named balance of. And here, yeah, we have a function named balance of, and it takes in the address and outputs us a balance. So we're going to go contract.balance of, and we're going to pop on our address there. And this is an async function, so we're also going to do .then, like we did before. And then in here, we can pop in our value or mid balance. And then what we can do, for now, we're going to just console log the balance. Auto formatter. And then we'll also put just a catch statement in case we did something wrong. I'm just going to log that error. Cool. So now if we check our console, we get back a value. Now this value is in hex, and that's how most UINTs are. All of the numbers that you receive from a contract will most likely be in hex. So what we can do is this value comes with a function on it, and we can just put .toNumber. And then if we refresh, connect our wallet, and it will didn't save it. Let's make sure I save it. Cool. Yeah, 200 there. And so what we'll do is we'll just change that to set balance, set token balance. And then we can put down here, make sure that there is a balance available. And then we can do display our text. Balance. Token balance. Well, if we save that, oh, okay. I can put this outside of that connect button. Boom, and we have a balance of 200 tokens, which makes sense because in our mint function, or when I deployed the contract, cool. So that would just be how to do a read function. Again, it was probably got a bit more confusing with the React in there. But all you need is that Ether's provider. You can get the signer, which we haven't really needed yet. This will be needed for writing functions, and then that contract object. And so that contract also needed the contract address and the ABI. Those are the main differences between a Web3 project and just a normal front end. Everything else that I've written would just be normal front end work. But those three things are the biggest differences. And so we'll just go into, I'm not going to go super in depth past this point, but I'm just going to add in one more function. And this will be a write function. So we're going to allow the user to write to the contract and send their tokens. So I'm just going to add in the UI for it first. So we're going to make sure that the contract is connected. And then we'll display two things. We're going to use a flex container, Chakra. And then we'll just do a direction. And then some input. And we'll want this as our text input. We're going to give it just a margin top of 5 and a placeholder of address. And then when it changes, we're going to want to do something. We're just going to give it an empty function for now. And then our value, just going to give it null. I think that should be fine. Then we're going to go with a number input. And this is just another one from Chakra. We'll give it a margin top of 5. On change. Their value of null for now. And then we're also going to add a placeholder of amount. Cool. And then the way Chakra works, we're just going to do a number input field. And we're going to set a, oh, sorry, we place a placeholder here. And we're also going to just put a max of token balance. Cool. And then we also want a button. 5 again, and on click. And we can just do this. Cool. And we got to import all those. Should be good there. Let's see, what did I do there? I believe I can't give these no. Okay, cool. Okay. So we have these, just this basic UI here, where we can input an address, an amount, and then we can send. So we're just going to add those inputs as state. So we're going to go const address input. And then we can also do the amount input. And then what we'll do is we'll set this value to amount. And on change, we're going to take the value and we'll go set amount input to value. Then on the input, we just have to do it a bit differently. It takes an event instead, and then set address input to event dot target. Then we're going to address input there. Where did I put amount? Should be amount input. Boom. Now if we do that, uncontrolled, it should be. Why would that be? Not sure why it's giving me that. We should be fine. Oh, I need to change that maybe. I named that incorrectly. Okay. And ignore that for now. We should be fine. Cool. What we're going to do next is just create the function to send the tokens. So we're going to add in this button, send tokens. Then we can add this function in here. Send tokens. And this should make sure that we have a few things. So we're going to go if address input, token input, amount input, sorry. Input, contract, and then we also need the signer. Now we need the contract. We need to attach the contract to the signer. So what we're going to do is take the contract. We're going to call it token with signer. And this will just take the contract, and we can call connect on that with the signer. Then we can simply call token with signer dot transfer the address input and amount input. And so now we can take, if we want, we can take another one of these addresses to send to. We're just going to input that there. This might be, may have messed something up there. We can take a look in a bit. And then I'm just going to send them one token, and let's see. Cool. Yeah, no, it's working fine. So this transaction pops up, and what we can do, it'll tell us an estimated fee. This is like most transactions on the network. And we have some data in here. We have our address and our uint. This hex data is these values converted to hex. And it'll tell us that our total is 36 cents. So we're doing this on the test network, on our local network, actually. So obviously it's much cheaper. On Ethereum mainnet, this would probably cost like $40. But yeah, since we're doing this on our local network, it's much cheaper. And I can go confirm. And then if I check in my Metamask, I did do something wrong. I believe the address isn't getting checked, set properly. So let's just see, make sure what the address input is. Okay. Let's say we do this one. 2. Interesting. Ah. A little bit of a bumpy one. This is the right account. Yep. I'm going to check on Firefox again. Still get that weird error. Oh. Let's see. Do 10. Oh, we only have 200, so let's do 22. It seems to be giving me an error. But theoretically, this should be working. And we're going to just assume that it did. There could be some buggy stuff, and I don't really want to go too deep into this. So I'm just going to leave it there. This didn't go as smoothly as I had hoped for the second version. Hopefully you got some more insight on the first drop when I was much more energetic. But yeah, I would thank you for joining me anyways. I would highly recommend taking a look through, there's a bunch of like Udemy and a bunch of new or established courses that are now offering Solidity and Web3 stuff. So yeah, I'd recommend taking a look, as well as I sent some links with my last workshop. Those still apply the same to this one. So you should be able to find those in the DSC Discord. If you, yeah, I would take a look there. And yeah, as I said in the last one, this space is just incredible. And I didn't really do it justice with this workshop. But yeah, it's nuts. It's had given me some really great opportunities. And I would recommend it's more exciting than anything else in tech I found. And you can make some good money in it too. So yeah, thank you for joining me. And I'm just gonna cut it off now. But yeah, hope to see you in the future DSC workshops.